We're in part 7, page 572 of special senses, and we're focusing on the region of the anatomy that's related to the ear, hearing, as well as next to hearing would be balance and equilibrium. So let's do a quick little review here of structure. The external ear, including the thing that we're familiar with, the auricle, the pinna, and all of those, the helix, the earlobe, the tragus, and so on. So I want you to be aware of that. We have the external acoustic meatus, which when lined with skin provides us with the the external ear canal. And then we turn the page and we come across the term ceruminous glands. And the ceruminous glands are a type of sebaceous gland. They produce a waxy output, presumably to protect us from insects that might cause us some harm if we were sleeping on the ground and they sort of took a little walk inside of us. So earwax is the deal. Sometimes it requires, for people who have overproduction of the ceruminous output, that cerumen, that they need to have a little bit of cleansing. There's special techniques for that. Okay, beyond that entire procedure ends with the tympanic membrane. Now we're going to look at the middle ear very closely here with this diagram that I mentioned in the last episode. So here we have the middle ear. We're looking actually from the perspective of the middle ear. All right, and so down in this direction, over this way, we have the eustachian tube, or the auditory tube, connecting the nasal pharynx down this way with the middle ear here. We're behind the, now inside, shall I say, the tympanic membrane, and you can actually see the malleus placed right here. You can actually see the malleus up against the incus, or the anvil. The anvil then, or incus, is attached to the stapes, or the stirrup, and they're not showing us. We're actually, in essence, the oval window. So this would be up against whatever it is that we're standing in front of, presumably the oval window. Okay, so these features here are intended to magnify the sound when it's, how shall I say, it reverberates against the tympanic membrane and provides compressions and rarefactions in the fluids beyond the oval window. So I want you to pay close attention then to this muscle right here called Tensor Tympani. And then I want you to note that we have another little muscle right here. Let me get the focus on that. And the deal is with that muscle right here, we have the stapedius, it's what it's called. We have innervation of both of those muscles by the cranial nerve number 7, facial nerve. It has a special branch. Remember that facial nerve is entering the internal acoustic meatus along with cranial nerve 8, vestibulocochlear. Facial nerve actually then just sort of hooks around and comes out through the stylomastoid foramen in the front of the ear, takes care of muscles of facial expression. But it does have this little branch here called chordae tympani, C-O-C-H-O-R-D-A-E, tympani. And the deal is that they are going to cause these little muscles here to contract at moments when there is a very loud sound. And the idea is to protect these little delicate ossicles here by, how shall I say, quickly contracting and holding them still. Okay, so the chordae tympani goes on, this little branch right here, it goes on down through the lower into through the skull, and it actually jumps on to the mandibular branch of trigeminal. That's division 3 of trigeminal. Goes down before the mandibular enters the mandibular canal. There's a branch that goes, it's called lingual, it goes to the tongue. And so this nerve here travels with it. It jumps on board the lingual nerve and goes to the tongue, the anterior 2/3 of the tongue, and innervates the anterior 2/3 of the tongue for taste. So that's how cranial nerve 7 manages to get down onto the tongue, is through the chordae tympani. It's a very important detail, and I can provide you with, how shall I say, a Gray's Anatomy picture of that little workup. Wikipedia had that wrong for a number of years in the early 2000s, and I actually joined Wikipedia in order to request that that be rectified. It was rectified, and then my students stopped having, how shall I say, bad moments on tests once they rectified that. It is a slightly, how would I say, detailed little piece of information, but it's something that every medical student presumably learns when they do dissection of the cadaver, is that we're supposed to find the chordae tympani and the coming up through the tongue to the trigeminal nerve. Okay, so that takes care of this little detail right here. Let's press on over here. This is one of my favorite visuals of the book, in some ways just because I'm fascinated by the idea that we have something called endolymph. Let's pick up the action here. Do you remember the stapes was going to go to the oval window, beyond which is a lot of this network through here. The stapes in particular is going to connect with the cochlea and cause vibrations through the liquid here. So whatever you see inside of the blue area, which is inside of the labyrinthian duct system, the duct system, that's a space that's filled with what's called endolymph. Outside the blue area, there is an outside, do you see it? There's a space outside here. That's going to have paralymph in it. So two different types of fluid. Now I want to bring to your attention that the fluid that is of the blue color here inside the this little serous membrane filled with this endolymph. The endolymph has virtually no sodium. The electrolyte of interest here is potassium. Later in the book, we're going to learn that potassium-rich fluids are characteristic of intracellular fluid. Right, so 60% of all the water in the human body is inside the cell. Isn't that astounding? And less than 50% of the water is outside the cell in the intercellular spaces. Okay, so this would be outside, out here, or out here, or out here. When you're inside these blue areas here, you're having endolymph, and then outside of the spaces we have paralymph. Paralymph is rich in sodium, so I want you to associate that with extracellular fluid. Okay, and I'm just fascinated by the idea that we have this thing which is more than microscopic. It's actually a part of the gross anatomy, that we actually have so much endolymph, so much intracellular fluid-like substances. Okay, there's going to be innervation throughout the cochlea here. There's little areas of innervation here. Do you see that? Little areas of innervation here. And so we have a division here. Here's the facial nerve, which is about to just sort of go off into a different direction entirely. And then here we have the cranial nerve number 8, vestibulocochlear. So this is the cochlear part here. Out here we have these two sections, which are the vestibular part, superior and inferior. Okay, so the vestibulocochlear nerve divides up into its parts. You'll notice that there's a portion here, the inferior vestibular, that goes to these little devices here for static equilibrium. So they're called maculae. Okay, and then out here we have crista ampullaris, and basically they go to the semicircular canals, which that's set up to sense gyroscopic movements of turning corners and curving around, and so this is referred to as dynamic equilibrium. So static equilibrium, dynamic equilibrium. I prefer to use the terms balance, but equilibrium is a steady state in biological sciences, so it's fair to use that. I'm so much of a biochemist. So at any rate, moving right along, that provides us then with what we need to know from that picture. And we'll press on to the next section here, section part 8.